Welcome to GoSimulation.com. In this video, we'll learn the basics of SolidWorks simulation in under 11 minutes by simulating a linkage arm being pulled with a force of 500 pounds. We'll then analyze our simulation and make a few changes to the geometry. We'll then rerun the analysis and see how much material we've saved. If you enjoy this video, please sign up for a basic account of GoSimulation and get the first 2 lessons of my course on SolidWorks simulation absolutely free. The first thing that we're going to do is measure this part to see how much it's going to weigh. Now, in order to do that, we're going to go up to the Tools drop-down menu at the very top here, and then come to Mass Properties. Now, we do not have any material defined to this part, so the density of the material is assumed to be 0.04 pounds per cubic inch. Now that's a pretty low value. In fact, that's not going to be correct for about any of the materials that we would apply to a part like this. So instead, what we're going to take a look at is the volume. So we'll just make note of this volume as 6.92 cubic inches. Okay, now we're going to go ahead and close this, and we're going to turn on the simulation add-in. Now to turn on the simulation add-in, there are a few ways you can do it. The fastest way to do it is to come up here to this little caret and then click Add-ins. And then what we're going to do is find the SolidWorks simulation add-in right here and make sure to add a check mark on the left-hand side. And then we can click OK. Now, we notice that there is a simulation tab that gets created at the top here. We're just going to go ahead and click that on the command manager. And then what we're going to do is click this little caret below Study Advisor and then create a new study. And now we're going to name this Simple Simulation. And we're going to make sure that the static option is pressed in right here, and then we're going to click the OK button. This is the SolidWorks simulation user interface. It's broken down into 3 distinct sections. We have this section, which is the simulation feature tree. We have this section, which is the simulation command manager, and then we have the simulation drop-down menu at the very top where we can access the same commands. Now, all of the commands that we're going to access can be accessed through any one of these menus. It's just up to us how we want to work. I like to use the simulation feature tree on the left-hand side and then enter things as needed. Now what I like to do is start at the very top of the feature tree and then work my way down. And that's what we're going to do here. Now before we actually get started in inputting values into these sections, what I'm going to do is discuss what each of these sections mean. Now at the top we have the Materials and Bodies section. This is where we can apply materials to the part. It's also where we can make certain geometric changes to the part. Below that, we have the connection section. A connection is used to define part-to-part interaction. In this case, we only have one part modeled on the screen, so we're going to skip over connections. Below connections, we have fixtures. A fixture is used to define part-to-ground interaction. Now, what I mean by ground are parts which are not modeled on the screen. A fixture essentially is a way to hold a face, an edge, or vertex in place from moving. Below that we have the external load section. An external load is used to define a force or a pressure, and in some cases it can even be a temperature. Below that we have the mesh. Now the mesh is just a way for us to take the complicated geometry which we have on the screen and break it down into easy to understand elements so that we can calculate the stress, the strain, and the displacement in each one of the elements. Let's start out at the top and apply material to this part. Now what we're going to do is right-click on the Simple Part video part and then select Apply Edit Material. And what we're going to do are essentially apply the material properties of alloy steel to this part. Now you'll notice that we have some sections highlighted in red. Now these are the material properties that we need in order to run a simulation. And in this case, alloy steel has all of these material properties, so we can simply click Apply and then Close. Now, moving down, we have connections. Remember, connections are used to define part-to-part interaction. And in this case, we only have one part, so we're going to skip over connections. We're going to jump down to fixtures. Now in this case, we're going to have a fixture on this face so that this bracket is held in place. Now what we're going to do is right-click on fixtures and then select Fixed Geometry. And then we want to ensure that this Fixed Geometry button is pushed in, and then we want to make sure that this window is active, so we'll click in it once. This section should be blue, and then what we'll do is we'll select this face, and it should show up here. And then we can click the OK button. And then we have a fixture applied to that face. The next thing that I'm going to do is apply an external load of 500 pounds to this face in the negative Y direction. What that's going to do is it's going to take this linkage arm and it's going to pull it. Now in order to apply this force, we're going to go ahead and right-click on external loads and then select force. And then what we're going to do is we're going to make sure that force is active here, and in this window we're going to go ahead and select this face. Now by default, a force will be applied to a face in the normal 2 direction, and that's not what we want. We want the direction to be in the negative Y direction. So what we're going to do is select this option to select direction, and then in this box right here we're going to select this edge because the force is acting along this edge. Now we can see that the arrows are pointed in the general direction, but we want the arrows to go in the opposite direction. So what we're going to do is just scroll down and then select this reverse direction option. That's going to take the arrows and it's going to make sure that we have a pulling force on this linkage arm. The next thing that we're going to do is enter in our force value of 500 pounds. And once we have that, we can click the OK button. Finally, we can go ahead and mesh and then run this simulation. In order to do that, you can go ahead and right-click on Mesh and then select Mesh and Run. Now that we've run the simulation, we can see our results on the screen. We're looking at something called the von Mises stress. As we can see from this plot, we have a maximum stress along this fillet. And from this legend on the right-hand side, we can see that the maximum stress is 1.97 times 10 to the third pounds per square inch. Now, is this a safe design or is it not a safe design? Well, we can take this value and compare it to the yield strength. The yield strength is generally regarded as the highest amount of stress a certain part can withstand before it doesn't bend back to its original shape anymore. And so in this case, our stress is well below the yield strength, and so we know that we're operating within safe limits. Let's go ahead and try to make some changes to the model to either reduce the model's weight or to reduce the amount of maximum stress seen in the model, preferably both. Now in this case, I can see that the model has very little stress around the outside of these edges right here, and it has a maximum stress here. So what I'm going to do is I'm going to make a change to the fillet and make the fillet a little bit bigger, and what I'm also going to do is I'm going to take the outer diameter of this circle and reduce it down a little bit because we can stand to have higher stresses in these regions. Now in order to do that, I'm going to need to go back to the Model tab right here, and I'm just going to go ahead and select this sketch from the tree, and then what I'm going to do is I'm going to make a change to this outer diameter first. I'm going to change this to 2.25, and the next thing that I'm going to do is I'm going to make a change to the fillet. Now in this case, I'm going to want to change the fillet size from 0.4 to maybe 1 full inch. There we go. Now that I've made a change to the fillet, let's go back to the simulation, and all we have to do now is click the Run button. And now that we've rerun the model, we can see that the stress really hasn't changed too much. It's been reduced by a little bit, but not too much. Let's measure this part to see how much volume this part takes up. And remember, to do that, you go to Tools and then to Mass Properties. And in this case, we've brought the volume down from 6.92 down to 5.82. So we've reduced the volume and therefore reduced the mass. Thank you for visiting GoSimulation.com. If you enjoyed this video, make sure to sign up for our newsletter, where you'll receive updates on blog posts as well as special offers and deals.